Well, let's get started. So last time we talked about the intersection of a line and a plane. And today we're talking about the intersection of two planes. So to recap what we did last time when we were talking about a line and a plane, if I wanted to find the intersection of a line and a plane, I had two different ways to do it. There was the edge view method, and that was where we found the edge view of the plane, and then we were able to see where the line actually intersected the plane. And then the second method actually worked a little faster, and that was where we said the line isn't actually a line, it's the edge view of another plane. And if it's the edge view of another plane, then we can project those intersections back, and that was a quicker way to find it. Well, today, we're basically going to do that second half. We're going to find the edge view of one of the two planes, and then we can project those intersections. So you've kind of already done this. We're just going to do it with two planes now instead of a line and a plane. So, again, there's our solution principle, finding the edge view of one of the two planes. So if I have two planes that intersect each other, and I want to find exactly where they intersect, then the first thing I'm going to need is a true length line so that I can find an edge view of one of those two planes. And it doesn't really matter which one we go off of. It doesn't matter which direction, which plane you go into. Next week, we're going to talk about the angle between the two planes. So that'll be the angle that we measure, not actually the angle relative to horizontal or anything, but just between the two planes. So it really doesn't matter which way you go. So I'm in the habit of creating my strike line in the front view to go up to the horizontal. So here you can see a horizontal strike line projected up. Here's my true length line. So now if I create a hinge perpendicular to that, then I expect ABC to be in edge view. And once I have the edge view of ABC and I've got the other plane brought across, now I can take these two intersection points and project them back. And the trickiest thing on this is projecting them back to the right spot, because as I project this intersection back, there's a lot of things that it can hit. So what you're projecting back to is not to plane ABC. You're projecting back to the edge of the plane that it intersects. So as I take this point back, it's intersecting edge GH, so we're going to take it all the way back to edge GH here. So then this intersecting line right here intersects with GE, so that's going to project back to where it intersects with GE. Now I've got my intersection line between these two views, and then I can go ahead and project those down to the view below. So where this intersects GE, I'll bring it down to GE. Where this intersects HG, I'll bring that down to HG. And there's my intersecting line right there. Then we're going to solve for visibility. So just like we did with a line and a plane, except this time we're looking at which plane is on top rather than a line versus a plane. So for example, on this intersecting line, plane EGH is on top either to the left of this intersection line or to the right of the intersection line. So I need to figure out which one's on top. And I could actually take 1, 2, 3, 4, 5, 6 possible apparent intersections to figure that out. So same thing down here. EGH, it's either on top from here to the left or from here to the right. And I just need to take one of those apparent intersections to figure that out. So solving for the top view first, as I take this line down, does it hit AC or EH first? It hits AC. So that means plane ABC is on top to the right of this intersection line. So if ABC is on top, that means that I'm going to close out any ABC lines, but then I'm going to trim the opposite plane. So I'm going to trim any EGH lines over here on the right side. So I trim out those 3 little lines right there. If I trim out EGH on this side of the intersection line, then I'm going to trim out any ABC lines on the other side of the intersection. And again, just for the heck of it, to double check myself, if I took this intersecting point right here down, does it hit EG or AB first? I expect it to hit EG first because I just said that this plane was on top. And as I come down, I can see that it hits EG before it hits AB all the way down here. So now I need to solve the visibility for this front view here. And again, I can take any of these points. I probably wouldn't have picked this point just because it's so close to the intersection. It is to the right of it, but it's kind of hard to tell. I probably would have picked something a little more obvious like this point. But nonetheless, I've got EG versus CB. I go up and CB is on top to the right of this intersection line. So if ABC is on top, then I trim out any EGH lines. So I'm going to trim out these two little lines right here. If I trim out EGH on this side, then I'm trimming out ABC on the other side. So I'm going to trim out that little line right there. And now I've completed my views. So like I said, next time we'll talk about the angle between these, but that's the concept of the day. Again, not totally dissimilar from what we've been doing with a line and a plane, just a few more extra steps since we're dealing with more points. So let's do one together. So if we got a new and our templates folder and the additional files folder, I have a file in here called intersection planes. So as I take a look at this first example here, I don't appear to have any, first of all, obviously I don't have any edge views. Second of all, I don't appear to have any true length lines, so I'm going to have to create my own. So once more, I'm going to create a horizontal strike line in my front view. It really doesn't matter if you do it to ABC or XYZ, just because it looks like it might be a little cleaner to do ABC. I'm going to go with A straight across. And then where that hits BC, I'll take that up to BC, and then back to A. And that will be my true length strike line. So I'm going to go ahead and erase the first couple of parts of those to clean up my screen. So here's my true length strike line. I now want to create an auxiliary view perpendicular to that. And again, it really doesn't matter if you go down to the right or up and to the left. I think I'll go up and to the left. There's a little more space that way. So I'll create a hinge perpendicular to that true length strike line. And then now I'm ready to project. So once more, I'm going to do one plane at a time. You can do one point at a time if you want to make sure you keep things straight. I'm going to go ahead and do all three corners of ABC. And since I'm going perpendicular to the strike line on ABC, then I'm expecting to get an edge view. If I get anything else, then maybe I've got a bad hinge or I projected something incorrectly. So going 2 views back, it looks like B is my closest offset. I'm going to offset that into the current layer this time. A, did I get the right, oops, looks like I grabbed the wrong point there. A is my second, and then C is the furthest one away. So B, A, C in that order. So I'll place some points at those intersections. B is the close one, then A, then C. And again, those should all line up. If they don't for some reason, then I need to go back and do some checking. So let's see, I'll draw from the first one to the last one, and looks like my point lies perfectly on that line. So far so good. What was that, Blaine? I'm sorry.
Oh, mine for XYZ didn't line up.
But XYZ won't, because we went perpendicular to the ABC strike line. So ABC will be an edge view, but XYZ will be a plane. Good question. So yeah, XYZ will still be a plane. So I'll do some quick labeling here. Again, you guys don't have to label on this sample one, but I will just to keep some things straight. And then I'm also going to erase my strike line. Again, once I've got my perpendicular hinge, I don't really need this strike line anymore, and I'm a little concerned that I'll accidentally think that's an intersecting line. So I'm going to get rid of that. So now I'm ready to bring XYZ over. So again, you can do this one at a time, or you can bring all three over at the same time if you want. And offsets, looks like Z is first, then Y, then X. So Z, then Y, then X. And I say that more for myself than you guys because I don't want to forget. So Z, then Y, then X. Now the labeling is very important this time because I'm going to be taking these intersections and projecting back, and I need to make sure I project back to the right points. So I am going to at least make sure that I have my X, Y, and Z labels there. I'm just not going to worry about the suffixes for right now, just to keep things moving. X, Y, Z, back to X. So now I've got ABC and edge view. I now can see two intersecting points, so I can now project those back to the previous view. So I'm going to take the first intersecting line here and project back perpendicularly. Again, you can do these one at a time and place points, or you can do both of them at the same time, whatever you feel most comfortable with. I'll go ahead and do both. And then I'm going to draw in my intersecting lines. So once more, I want to see which edge of the plane is it intersecting. So this first point is intersecting edge XY. So I'm going to project back to XY over here. So that would be that point right there. And then the other one intersects XZ. So I'm going to take that one back to XZ. So that gives me an intersecting line like so. And then now that I have those two intersecting lines, I can project those back down to the front view. And then once more, I'll draw a line to connect those. So this one's coming from XZ, which is right there, and the other one is XY, which is right there. So now I'm ready to solve for my visibility. So I'll do my horizontal view first. And again, I've got 1, 2, 3, 4, 5, 6 possible points to project. I'll just pick one. I'll pick this one right here. So again, when I do this, I'm solving for what's on top below this intersecting line in this area right here. So do I hit AB or XY first? As I look down, I hit AB first. So that means plane ABC is on top on this side of the intersecting line. So if ABC is on top, then I trim any XYZ lines that are inside the intersection of these two planes on this side of the intersection line. So if I hit trim and press enter, that selects everything as a cutting edge. I'm going to trim out this XY line and this XY line. If I trim out XYZ on this side of the intersection, then I'm trimming out ABC on the other side. So here's an ABC line right there. There's another ABC line. And that would complete this view. Now solving for the front view. Again, I'll start array at one of these apparent intersections. I'll say this one. Do I hit BC or XZ first? As I look up, looks like it hits BC first. So ABC is on top above this intersecting line, so that means I trim out XYZ. So trim and enter, trim out that line and that line. If I trim out XYZ on this side, then I'm trimming out ABC on the other side. And that would complete my views. Make sense so far? Kind of? Well, let me do one more quick example. You guys can just watch me for this one. This one, as you can see, I've already got an edge view of one of these two planes. XYZ is already an edge view, so I'm going to project these edges back and then create my intersecting line. So where this crosses AB and this one crosses AC, I get something that looks like this. So what I want you to see on this one, it's a little different because this intersection line is all the way over here. It didn't just stop right here. So let's make sure that I projected properly. This came off of AB and I took it to AB right there. This one came off of AC and I took it right there. So if you end up with a situation like this, this typically means that one plane doesn't completely pierce another plane. They kind of overlap each other, if you will. So this is still my intersecting line, and solving for visibility, I'll take maybe this intersection up. So between BC and XZ, what does it hit first? It hits BC. So that means on the right side of this intersecting line, ABC is on top. So that means I trim out any XYZ lines. So I'm going to trim XYZ. If I'm trimming XYZ on this side of the intersection, then I'm trimming out ABC on the other side. So I'll get rid of that one. And then the last thing that I need to do is, this helped me project and figure out where the intersecting line is, but it doesn't actually stay there, so I'm going to trim this piece out as well. So there you can see I've got, a little bit where they don't intersect each other. They're kind of overlapping and intersecting at the same time. So if I had a hidden line in here, I'd be able to see that continuing back, and this one continuing back behind it. And then I would see this line as a hidden line for this plane cutting through there. So you will have at least one today that overlaps like this. And again, as soon as you have an intersecting line that goes past the two planes, then you know you're going to have an overlap situation, which really just means you might have one extra line that you have to trim out. All right, I can't recall if I had solutions. I do. So if I thaw the solution layer, you can see the solutions up above. If you need to go back and look at them. I also had a solution 2 layer. I can't recall what I did with that one. So, oh, that's to get into the angle stuff. We're going to do that next time, so we'll ignore that. All right, so the plan today is to do a couple more intersection drawings. So if we go to new in our class folder, we did intersection 1 and 2 last time. Today we're going to do 3 and 4. So let's talk about them for a minute here. On intersection 3, you've got 3 problems that you're going to do. You can see that 2 of the problems already have edge views. So the first one here, you've already got UVW and edge view, so you just have to find the intersection and solve for visibility in the horizontal plane. The one down below, where you got the front and the profile, you've already got an edge view and the profile view, so you just need to project over and then solve visibility for the front. And then the third one over here, you don't have any edge views and you don't have any true length lines, so you're going to have to construct a strike line, and should be enough room to project over here to finish these views. So you'll need one more view that has an edge view and then be able to project back. And then the second one is actually just one more problem doing pretty similar stuff. So 2 intersecting planes, find an edge view, and then project your intersections back. Now this one already has some true length lines on it if you look at it. So GF is parallel to the profile, so GF over here is true length. You can go perpendicular to that. XZ is parallel to this hinge, so that means XZ over here is true length. Might be a little easier space-wise to go perpendicular to that one and go this way, but any of those methods are fine. The other thing I want to mention back on intersection 3, if I remember correctly, this third problem right here is like this one, where it's 2 overlapping ones, but not fully piercing. So something to watch out for then on this third one. All right, that's the plan. Let me know if you have any questions.